Good morning, everyone. So as you can see, I am going to talk to the title, Coastline Responses to Climate Change in South Africa. Here, of course, we're focusing on coastlines. And of course, coastlines lie at the interface between the land and the sea. And so therefore, coastlines are very sensitive to processes that take place on the land and processes that take place on the sea. So this, of course, means that not only are coastlines very dynamic places, this means they are also subject to influence by a range of different types of forcing factors coming from different directions. So here, of course, that may include climatic forcing factors, and this is, of course, what we're sort of mainly going to focus on here. But it may also be affected by non-climatic forcings, both directly and indirectly by things such as human activity. And I'll be talking about these forcing factors just in a second. An additional point, of course, is that the coastline is very responsive, not only to these forcing factors directly, but also the interplay between different forcing factors and any feedbacks that exist between forcing and response. In other words, for example, changes in the shape of the nearshore environment as a result of wave erosion, and this of course may have an influence upon the processes that take place in that coastal zone thereafter. So here these types of feedbacks are actually very significant in terms of influencing coastal morphodynamic behaviour. So the net outcome of this interplay between a range of different forcing factors that affect the coastline and coastline physical properties and dynamic behaviour means that here we have changes in the properties of the coastline, reflecting both the physical attributes of the coastline and also, of course, their ecological attributes. So here these arise as a result of the dynamic behaviour of the coastline in response to forcing, which in turn demonstrates any potential sensitivity of the coastline and its properties to disturbance by these forcing factors in the first place. So to explore these issues in a bit more detail, in this presentation here, we're going to kind of pose this fundamental key question that's going to guide the elements that I'm going to talk about subsequently. So this question, of course, reads, how sensitive are coastlines to ongoing climate change? So this is actually a very fundamental question because it has relevance to answering a number of important elements related to examining coastal morphodynamic behaviour and how we then go about managing the coastline and its physical and ecological and, of course, human properties. So this question is of relevance to understanding the future evolution of coastal systems under ongoing climate change. It's relevant to then, on the basis of that, quantifying the rates and locations of geomorphic change, because we may anticipate seeing spatial and temporal variations in the ways in which coastlines respond to external forcing. This then has implications for evaluating the effects of forcing upon coastal landforms and ecosystems, and of course properties of coastal ecosystems such as ecosystem services, biodiversity, carbon storage, and, you know, of course, the list goes on. We also may have implications for considering changes in coastal properties, such as grain size or beach slope or beach shape, in reducing coastal hazard risk, such as coastal flooding or cliff erosion and things like that. And of course, all of this provides the context for enabling better decision-making and facilitating the sustainability of coastal communities. So these are kind of the end users, the end products of the scientific evaluation of coastal morphodynamics. So in order to try and achieve some of those things today, this presentation is going to focus on these four sequential elements. So first of all, I'm going to say something about coastal forcings and the dynamics of coastal systems. And then we'll consider how different coastline types may respond to forcings in different ways. And this demonstrates what is termed their sensitivity. And then we're going to consider how sensitivity of the different coastline properties can be used in order to identify their resilience, in other words, their ability to withstand coastal forcing. And then finally, we're going to talk about the implications of all of this for policy and management. So I'll start off with the first bullet point here on the list. Now, as mentioned, coastlines like the interface between the land and the sea. So we may have variations in things that take place on the land and variations in things that take place in the oceans, impacting upon the coastline. And that's kind of shown schematically in this little diagram here. So in terms of forcing factors coming from the land, we may have things such as, and there are many other things as well, variations in incoming river water and sediment, obviously focused along river mouths and estuaries, that bring water and sediment to the coastline. We may have changes in land use in the coastal hinterland related to agriculture or forestry. We may have coastal development, such as urbanisation. And of course, associated with urbanisation, we may have the development of built infrastructure and engineering. So this may relate to, of course, port and harbour facilities, as well as urbanisation and other elements of the urban infrastructure. And of course, the ways in which those things may be demonstrated along the coast in terms of engineering, which may include things such as seawalls, revetments, and so on. Now, of course, the land and the coastal hinterland may, of course, be affected by extreme weather and climatic events, which may in turn impact upon the coastline. So this may include high rainfall inland and, of course, high amounts of river water coming towards the coast, or it may include things such as mass movements taking place on sea cliffs, for example. It may also include changes in things like deforestation, which may take place relatively rapidly, hence why I've termed it an extreme event here. In terms of forcing factors from the marine environment, of course, we have the climatically influenced factors of sea level, waves and tides. And of course, the tides are not climatically influenced themselves, although they can amplify those other two elements. And of course, we may also have the role of extreme events, such as storms, tsunamis, and similar kinds of things giving rise to high wave conditions. So here we have the interplay between a number of different forcing factors that may impact upon the coastline, its properties and dynamics. So in terms of the outcomes of these forcings and their expression along the coastline, here I've sort of simply listed the major types of expressions that are commonly used in order to identify the signatures of coastal forcings. So here, of course, if you just look at that bullet point, the first two words are the same: changes in something. In other words, coastal forcing results in changes in something along the coastline. And of course, it is that change that can then be monitored and identified. And therefore, the presence of a change is a signature that something is happening, that the coastline is responding to something. So I won't go through all of these things in detail, but very simply, we have variations in coastal properties. So the spatial things that we can measure and monitor along the coastline related to its physical attributes. Now, these changes that take place in response to forcing may mean that something is speeding up or something is slowing down, or we may have changes over space in something. So something gets bigger or smaller. So either way here, we have the physical expression of something taking place along the coastline in response to forcing. In other words, the coastline does not stay the same. It changes in some kind of way. Now, the most common way in which coastal geomorphologists, such as myself, use to monitor changes in the nature of the coastline is through examining the workings of coastal sediment systems. And the reason for this is that this corresponds to the amount of sediment that is moving from one place to another within the coastal zone, as kind of demonstrated schematically here, according to the colour codings on the previous slide. And as a result of sediment moving around, the expression of this is an increase in size or a decrease in size of a coastal landform. And of course, we can monitor and measure the changes in size and shape and location of landforms. And this tells us something about the dynamic nature of sediment moving around within the coastal system. So here, of course, if we have variations in coastal forcing, we can anticipate that these sediment systems are going to change. So we may get sediment erosion in one place and deposition in another place, for example. So here we have kind of some of the basic kind of numerical tools that we can then use to evaluate the responsiveness of the coastal environment to forcing by weather and climate events. So in order to consider this in a bit more detail, here we actually need to then zoom into examining the characteristics of individual coastlines in order to then examine the sensitivity of those coastlines to be affected by climate forcing. So if we look at the coastlines of southern Africa, schematically, we can see that we have fundamentally two kind of major types of coastlines. We have coastlines dominated by sand, and these are shown in the kind of golden yellow colour, and coastlines dominated by rocks, which are shown in the brown coloured line. So here along different parts of our coastlines, we have sandy and rocky dominated shorelines, which are of course characterised by distinctive assemblages of different types of landforms and related to those different types of ecosystems and other types of coastal attributes. In addition, we also have locations that have a mix of both rocky and sandy elements, and these are known as mixed coasts. We can also see here in these rose diagrams, we have different wind regimes found along the west, east and southern parts of our coastline. And of course, we also have spatial patterns of waves and tides that show some differences along the coastlines. So here this demonstrates that spatially, as we go along our coastline from one place to another, we have different types of forcings that characterize that particular type of the coast. So as a combination of variations in forcing plus variations in coastal properties, we can then anticipate that we have variations in different coastal responses as a result of those elements in combination. So what we can see along our coastlines is that we have rocky, sandy and elements where we have those two together, and they may have different facing directions and be affected by different types of forcings. So here, if we are looking at these different types of coastlines, we can then consider the relative sensitivity of those coastlines to be affected by those different types of forcings. So for example, this is a generalization, but generally speaking, rocky coastlines made up of hard rock are difficult to erode, and they are most commonly affected by weathering processes. So very often, the landforms found along rocky coastlines are relatively stable under so-called average or kind of normal conditions, and they exhibit relatively lower sensitivity to be affected by forcing factors. As a result of this, therefore, rocky coastlines tend to change relatively slowly over long time periods, which means that very often their landforms may be relict. In other words, they may not be at equilibrium with respect to present-day climatic forcings. In addition, of course, we not only have the longevity of rocky coast landforms being present over relatively long time scales or large spatial scales, but of course, this kind of quasi-stability might also be punctuated by extreme events that may give rise to very rapid mass movements. In other words, suddenly we have cliff collapse, for example, as a result of undercutting by large storm waves. By contrast, of course, if we are dealing with a sandy coastline, sand made up of unconsolidated loose sand grains is relatively easy to erode. And as a result of this, sandy coastlines often exhibit a quicker morphodynamic response and therefore a higher sensitivity to variations in forcing, even from one wave to another wave. So here, sandy coastlines may respond to a range of different forcing factors and forcing types, and may exhibit not only a more kind of dynamic functional behavior, but things like beach shape, for example, may exhibit what might be termed quasi-equilibrium over relatively shorter time periods. So here, rocky and sandy coastlines are kind of fundamentally different in terms of their physical properties, which have implications for the ways in which they respond to climatic forcing. So let's look at some pretty pictures of coasts. Here, of course, we have a steep rocky coast, and here we have another type of rocky coast where we have a relatively flat shore platform that is formed by rapid cliffline retreat. So here, of course, we have the dominant control of rock type and rock structure upon the types of landforms and the processes that take place along these rocky shorelines. By contrast, of course, in sand-dominated environments, here we have the presence of wide, shallow beaches, and in this case with vegetated backing sand dunes at the back of the beach system itself. We may also have narrower, steeper beaches with, as you can see here, we have a cliff line at the back of the beach. We may also have mixed shorelines as well, where we have a combination of both sand and bedrock being present in the same place. So in this particular example, we have transverse supratidal dunes that are migrating and sitting on top of an eroded bedrock surface that you can see in the foreground here. Or in this example here, where there are patches of sand located between the bedrock outcrops. So here, of course, the patches of sand are determined by the topography of the underlying bedrock, which is strongly controlled by bedrock structure. So resulting from this, here, this sort of survey of the different types of coastlines that we find along our shoreline nationally demonstrates that these different coastline types may exhibit different sensitivities to forcing, and as a result, they may respond and change at different rates and through different styles, whether that's by weathering or erosion or different types of mass movement processes. So as a result of this variability, what this tells us is that we need to adopt different approaches to things such as monitoring and modelling and coastline management, even along the same coastal stretch. In other words, the procedures that we may apply to a sandy shoreline are totally different than the procedures that we may apply to a rocky shoreline. In addition, of course, any coastal stretch may have different human elements present along that coastal stretch. So some of our shorelines are, of course, urbanized, some are rural. Therefore, we have different types of human activities, different types of infrastructure, and so on present as well. And this may vary not only coastal physical properties, but also the sensitivity of those shorelines to change. And the final thing to note, of course, is along different shorelines, where we have different processes and rates of change taking place. This means that any potential risks and impacts of forcing events may also vary. And this may tell us something about a hazard risk that might be experienced along different types of coastal stretches. So building from this consideration of different coastal types, I'm now going to consider how we can use this information to identify how to build coastal resilience. In other words, how do we make our coastlines stronger in order to withstand future climate change? So coastal resilience can be defined, broadly speaking, as the ability of a coastal system or component within that system to withstand the effects of ongoing forcing. So whether that's by a climate or whether it's by human activity. So here, as mentioned earlier on, the responsiveness of any coastal system can be measured through the outcome of forcing upon the system. In other words, if we have a big storm where we have big waves, what is the outcome of those big waves upon the coastline? So here we need to measure and monitor the changes that take place within the system, because this will tell us something about how resilient that system is to those forcing factors that are exerted upon the system. So here, if there is minimal response to forcing, in other words, if there is very little change, then this will suggest that the system itself exhibits high resilience. In other words, the geomorphic threshold for causing changes to the system has not been exceeded. In other words, that system is strong, it is resilient, it is able to withstand forcing. So what this tells us, therefore, is that there's a relationship between this idea of resilience and the sensitivity of the system to be affected by forcing. So here, these concepts of resilience and sensitivity are basically the flip side of the same coin. They can be considered, broadly speaking, as opposites of each other. Now, this idea of coastal resilience is actually very important with respect to ongoing climatic and environmental change. And the reason for this is that if coastlines have higher resilience, they will be more likely to withstand coastal forcing and less likely to exhibit change or result in negative outcomes as a result of that change. So here, higher resilience is a property of a shoreline that enables the shoreline to withstand any changes in climate that might impact upon that coastline. So here, increased climate forcing along coasts, which is what we know from both observational and modelling evidence globally as well as locally, suggests that there is an increasing likelihood that coastal change will occur. In other words, if sea level is rising, if storms are getting bigger, if waves are getting bigger, then here coastal forcing is increasing. So here, if forcing is increasing, it means, therefore, that coastlines will likely be less resilient. In other words, here the forcing is slowly reaching up to that level of critical exceedance of this system. In other words, here, increasing a magnitude of forcing will mean that these coastlines will be less able to withstand the effects of these big, extreme, ongoing changes in future. So here, greater coastline resilience can help buffer the negative effects of climate change. So if we want to protect our coastline, we then need to seek ways in which coastline resilience may be increased. So the next question is, of course, how can we go about increasing the resilience of our coastlines? So in the following slides, I've just considered some of the major things that can be done potentially to increase the resilience of coastlines. So in the case of sandy beaches, for example, on the right-hand side, we have a range of things that can be considered. So I won't go through all of these things in detail. You can look at the slides afterwards when they are supplied. But I'll just highlight a couple of things. So it includes, for example, right at the top, beach nourishment, building groins, planting in the supratidal zone, and so on. So all of these things can contribute to holding sand in place on sandy beaches. So the bigger, the higher, the broader the sandy beach, the more likely it is to exhibit resilience against ongoing climate change. Likewise, with respect to sand dunes, we can also do things to increase the resilience of sand dunes. So, for example, we can ban new sand mining, we can rehabilitate existing or closed sand mining sites, and these are important in Southern Africa, and so on. So we can do a number of things with respect to sand dunes. We can also do a number of things with respect to rocky shorelines themselves. So this may include things such as putting rock armouring on the landward edge of rock platforms in order to prevent big waves rolling across the platforms and flooding inland locations. We can also monitor the stability of rock cliffs or caves in order to have a full warning system, if you like, of potential cliff collapse. So all of these different mechanisms that can be used to enhance shoreline resilience are really focused on the physical landforms and ecosystems of the coastal zone themselves. However, coastal resilience also means more than just those physical features. So far, we've just focused on the first bullet point, the physical attributes of the coastlines themselves. However, coastal resilience can also be built by ensuring that assets and infrastructure along the coastline are able to withstand things such as flooding or coastal erosion. And of course, it also includes building the resilience of people and communities, making people more able to cope with these extreme events. So if we have a number of approaches that we can use to build coastal resilience, what is the indicators of successful coastal resilience? So here it focuses on maintaining the physical attributes and assets along coastlines, reducing risk, reducing impacts, promoting sustainability, and in order to do this, building collaborative partnerships. And this is absolutely key, and I'll talk about why this is important in a second. So one important approach to developing the resilience of coastlines is actually working with nature. So here involving nature as a partner in providing resilience along coastlines. Now, traditionally, resilience has been built through hard engineering structures, so building structures such as seawalls and so on, in order to reduce things like coastal erosion. However, of course, globally over the last decades, hard engineering has been kind of remodified into soft engineering approaches and using existing coastal landforms as green infrastructure. In other words, here, allowing the natural landforms found along coastlines themselves to act as buffers against things such as coastal erosion. And here is an example. So what we can see here is a big hump, which is a natural sand dune. So here, this sand dune ridge acts as a natural flood barrier between the sea and the land. So in this particular instance, this sand dune is acting as green infrastructure, protecting the coastline from external forcing. So here, this idea of green infrastructure is an increasing theme globally, focused on building up coastal resilience. And this is one example of what is termed a nature-based solution. In other words, the ways in which the natural features of the landscape, in this case a coastline, but this has also been applied to many rivers and other types of settings. Here, these actually provide positive benefits of, in this case, existing coastal landforms and their properties and processes that act to work with rather than against nature. So here the management strategy is to exploit the natural processes and properties of existing landforms in order to provide natural coastline resilience. And the benefits of nature-based solutions are manifold. It's cheaper and more cost-effective and less risky. It's easier to implement, requires less technology. It results in more positive and fewer negative outcomes, including for ecosystems. So this is very positive for ecosystem biodiversity. And critically, it can also involve local stakeholders more easily as well. So there are really many positive benefits. Thanks, I'm getting towards the end here. Many positive benefits that we can consider here in working with these natural landforms. So, of course, the final question that we can then pose, how can we enact nature-based solutions in building coastal resilience against climate change impacts? And of course, this is relevant to all types of coastal management globally as well as locally. So now I'm just going to make some final comments with respect to how we can use this for policy and management. So the starting point here for policy and management is that we need to understand coastal properties, processes, and morphodynamics in the context of systems. So we need to know how coastlines work, first of all. Then on the basis of this, we need to undertake environmental auditing. Then this can be used as the basis for monitoring for scientifically informed decision-making. So in order to have effective management, we need to collect information. And decision-making without scientifically valid and up-to-date information is flawed and will fail. So to all of the managers out there, you're probably doing things wrong if you don't use scientific information as the basis for your decision-making process. However, different coastal stretches will have different issues and properties. As we've seen, different parts of our coastline are different. They work in different ways. So this means that one size does not fit all in terms of management of coastal change. And this, of course, has implications for things such as NEMA. So in order to facilitate this, we need to work with and empower local communities and establish local priorities and building partnerships with those local communities. And this will allow for a sustained and consistent framework for collaboration with local stakeholders. However, and this is the kind of final content slide here, there are some unknown factors. So we don't know necessarily the trajectories of future coastal change and coastal zone change, such as land use and urbanisation. So we don't necessarily know how future climate forcings are going to pan out. We may also have a lack of predictability of coastal responses, given any future vulnerabilities or resilience or any potential geomorphic thresholds that may be present. So we don't have full information on how the coastline is going to respond to future conditions. We may have tipping points of coastal system behaviour that are difficult to identify. And of course, we may have different patterns of future political or socio-economic priorities. So just to summarise what I've talked about here, we've seen that coastlines are affected by events and processes that are generated from both the land and the sea. And here, a systems context for understanding how coastlines work is the basis for considering how these coastlines are going to respond to these forcing factors. I've considered the concept of resilience, and this is a really good idea to help us understand how coastlines are going to respond to climate, and building from resilience, considering coastlines as demonstrating green infrastructure is a really good way of much more effective coastal management. And this should be done by working with local communities. Okay, thank you for your attention.